All right, so we're getting into section 6H1. This is for honors class, and it's proving that all circles are similar. And you should be able to justify that two circles are similar and conclude that any circle can be mapped onto another circle using similarity transformations, right? So this is saying that all circles are similar, not necessarily congruent, but all circles are similar, because that you can you can undergo, or they can undergo all sort of transformations, and you can map one onto another. The big one being dilations, right? So what do we really base circles off of, like the proportionality off of circles? What do we kind of like what do we it's the easiest way to base circles. What are some ways that we measure circles? Well, you guys remember what we measure circles based upon their circumference, their diameter, and their radius. Well, so the way we can do, and then their center point, right? The way we can kind of like look at two circles, those two things, right? So we have a circle. The way I can tell that it's a circle is if I have, let's take a line, right? And let's say I have let's do a line here. Let's make it red. Okay, and then I have let's do a radius of, don't need to be that big. Okay, I have a radius of 3. Okay, so radius of 3, and then another radius of 3. Right, so to make sure that it's a perfect circle, then I need to have that circle have a radius of 3 from the center point. Okay, so that is going to be there from one spot, and then there to the other spot. Okay, so I know that. Make sure that that is the center, that is the center, and that over there on that side it's 3, and on the other side it's 3 as well. Right, so I have a 3 going this way, 3 going this way, 3 going this way, and 3 going this way. Right, so that's a pretty good circle, right? Because I have 3 going from here to here, here to here, here to here, here to here. And I'm just gonna kind of like delete these and just give me one circle here. Maybe just like fill that in, make one like this. Okay, so that is my radius is 3. Okay, then I'll have another circle. I'll have like a radius of 2. A circle, make a radius of 2 here. So diameter has to be 4 all the way across, all the way up and down. Okay, so that way, 4 this way, and 4 this way. All right. Well, let's say it's 6. This one's 6, and we'll say that one is 2. All right. So, oh my goodness. I really didn't pick a really easy one, did I? We'll just do like 1.5. 1.5 this way, 1.5 this way, 1.5 this way, and then 1.5 this way. Best we can get. Okay, so these two circles are similar, right? They're all similar. They all have some type of, ratio of the radius. you know, that you can you can apply some type of scale factor to the radius, or some type of scale factor of the diameter, or of the circumference, right? Because the circumference is the ratio of the circumference to the diameter, right? But this one here, you can see that I have a radius of 3 on this one, and I have a radius of 1/2, or 1 1/2 on this one. 1 1/2 on this one. Okay, so radius equals 3, and the radius on this one, radius equals 1.5. Right, so say I wanted to map this one onto this one. Okay, so if I wanted to map this one onto this one, and this is my center point. Right, this is my center point. My center point is 8, 9. Negative 8, 9. This one's center point is 5, 9. This one's is 5, 9. Right, so first I'd have to dilate this at a point of dilation of negative 8, 9. Right, so the center point, I want to dilate this at the center point. So every point on here, every single point on here is going to dilate inward at a scale factor of 1/2. Right, so it's going to shrink this radius by 1/2. Okay, so after it did that, it would be, the radius would then become 1/2. Right, so if I make a little blue on here, right, I make a little blue circle of 1/2. Right, 3, 1/2 of 1/2 of 3 here is 1.5. Right, now my new blue circle will be 1.5 all the way outside. So my diameter is gonna be 3. Okay, so that would be my new. You can see if I bring it over here, it's pretty close. Okay, but how much do I need to bring it over by? Well, that's my first one there. Right, my move, that's my first dilation. My first transformation was the dilation, and now I have to do a translation. Right, I could do a reflection and then a translation, you know, whatever I got to do translation too. Right, so my x value is not, my y value doesn't have to change very much. What I say is -9. It's just 9. It's just 9. My y value doesn't have to change. They're both on 9. Right, but I have to go from -8 to 5. Right, so my change in x is going to be 5 minus -8. So 5 minus -8. 5 minus -8. -8. -8. Or it's just like 5 plus 8. 5 plus 8 is 13. All right, so it's going to move 13 over. So my translation would be x, y, x plus 13, y plus 0, and that would move over. All right, so that's, so doesn't matter what size your radius is, there's some scale factor that you can figure out to shrink or grow the triangle or the radius to make them the same size. So all circles are similar. Right now, once you make the radiuses the same size, the radii the same size, then they're congruent. So that's pretty neat. All right, so let's take pause this just for a minute. So here's some examples of what you might see on your practice work. So this is saying, all, some, or no circles are similar. Well, this is all circles are similar. Okay, so this is saying given circle M is the pre-image. So this guy here is a pre-image. Right, let's zoom in and take a closer look at this. So circle M's radius looks like it is starts at -3 and it goes to -1. So circle R's radius, the radius of circle R equals 2. Therefore, the diameter equals 4. So there's some things that'll help us. All right, so how can it be mapped on to how can M get mapped onto Q? All right. Oh, the center point. We need the center point as well. Center point is -3 and 4. All right, so center point is -3, 4. So we need to match center points. So Q's center point is 5, 3. Q is 5. Let's change Q's color. Change Q's color to like red. Q's color is now red. All right, so Q is 5, 3. All right, so in order to get Q on M onto the center point of Q, you can do the dilation. Looks like let's see what's the radius? Let's see. Looks like the radius is 5 to 3, so they are the same radius. Radius of M equals 2. So they're congruent already. Not just similar. So we just need to translate this on this one, right? So the change in X between M and Y is going to be the X value for Q minus the X value for R, and the change in Y is going to be the X value, the Y value for Q minus the Y value for R. Okay, so here we go. This was what did I say this was? This was 5, oh, I already marked it there. Okay. All right, so here we go. So this is Q is 5 minus -3. That's 5 minus -3 is plus. 5 plus 3 is 8. Plus 8. So my delta X plus 8 plus 8. Right, and then my Q is going to be equals 3 minus 4 equals -1. So my delta y equals -1. So my going to be translated x plus 8 comma y minus 1. There we go. You could also say translated 8 to the right and 1 down. That would be fine as well. Okay, shift over to orange for circle T. Circle T is not congruent. They're similar. So what is the radius for circle T? It is 1, 2, 3. So circle T's radius is of T equals 3. Here's the diameter. Diameter is 6. All right, so that means the scale factor is going to have to be for the before. It's going to be the after. Scale factor equals after divided by before. My after is 3. My before is 2. So it's 2/3. So my first transformation is going to be x comma y. And it's going to be the all the points in the circle. So it's going to be just all the points Rx 3/2 x 3/2 y, right, at a point at point M, or point of dilation, point M, right? So it's gonna grow it, right? And then I have to, what is the point of the center point for point T is gonna be is -2, 1, or sorry, 2, -1. It is what's right here, 2, -1. Okay, so again, I got to do my deltas, right? So I'm just gonna, I showed it to you how to do it over here, so I'm just gonna do it here, right? So it's gonna be my change in x is gonna be 3 minus 2, -3, or sorry, 2 minus 3 negative. So it's going to be 5. You can also count 1, 2, 3, 4, 5. All right, so it's going to be an x comma y. X to the right, so it's +5. And y, my change in y is 1, 2, 3, 4, 5, x, y minus 5. You could also have done -1 minus 4. It's in the negative direction. Right, and that's a transformation down 5. Okay, and then how can we, and let's change to purple, I guess. All right, so purple mapping map M onto W. So mapping M onto W. You know what? The first one I did was on circle R. I did it on a circle Q. Oops. Oh well. Yeah, the first one should have been a shrink. And first one, 3, -4. 6. Yeah, definitely. What was I doing? Okay, M on the circle R. Yeah, that should have been a shrink of 1/2. M and Q are the same size. So 3 on the 4, that should have been a 1/2 shrink. I just noticed that now. Oh, so we should have applied a 1/2 scale factor to that one. Yeah. And I can't remember what we did. Okay. I don't remember doing anything with that one. Huh. Oh well, it's late. Yeah, so R, okay, circle M being mapped to R. Yeah, so circle M being mapped to R. Um, did I skip it? I don't know if I skipped it or not. Yeah, so circle M being mapped to R. So this one, it's a scale factor of 1/2, right? Because this is a 1, this is a 2, so we have to do a scale factor of 1/2. And then the translation is going to be 1, 2, 3, 4, 5, 6, 7 over and 1, 2 up. Okay, so anyway, sorry about that. I don't even remember doing that. All right, so then W for circle M. All right, so circle M, we're gonna have to translate. Looks like 1, 2 over. So your delta X is gonna be -2, and then down is gonna be 1, 2, 3, 4, 5, 6, 7. So delta Y is going to be 7. And then your scale factor, see, our after, this is a growth, so it's going to be bigger than 1. So we're going to 1, 2, 3, 4. So it's going to be times 2. This is 1, 2 to 4. That's a radius of 4. So it's going to be times 2. All right. So my dilation of 2 about point M, and translation downward. Okay, so that's pretty much how it goes. Pretty straightforward. I hope this makes sense. It's just all about the radius. You can use diameter if it's challenging, if you want to. It's just all about proportionality. I hope this helps out.